Well, it's 4 minutes past 2, and it looks like we have most everyone joining us on the call, so I'm going to go ahead and get started. Some other people may be joining us throughout the presentation, so if you guys hear that beep, that's just other people joining us. But in the meantime, I will get started. Today we're going to focus on the JMS Mega-SETTLERs, our plate settler system. Okay, so quick overview of Jim Myers & Sons. I'm looking at the list. So we have engineers from all across North America on the line. Recognize most all the names, have worked on projects with you guys over the past decade or so. So appreciate you guys taking the time to listen in on this presentation. A little bit of history. Jim Myers & Sons has been family owned and operated since 1962, so over 55 years. Some little fun facts. Every day, billions of gallons of water flows through thousands of JMS installations across North America. We have over 250 years of collective experience in the water and wastewater industry. The picture you're seeing there is our facility in Charlotte, North Carolina. I'm not sure if you can see, but in the background you can kind of see the city skyline of Charlotte. So that is approximately 80,000 square feet. The warehouse is the back portion, and the office portion is about 15,000 square foot in the beginning of the front of the building there. So we have all in-house design, engineering, and manufacturing. A little unique nowadays. A lot of companies maybe aren't manufacturing like they used to. So one thing we pride ourselves on is, all of our in-house design and manufacturing is done in the United States here in Charlotte. This is a map of all of our reps across North America. Most all of you guys have worked with these guys for many years, many decades. But just giving you an idea of where our reps are across North America. This map shows installations, 1,500 of the most recent installations of JMS equipment across Canada, across the United States. You can kind of see it follows population and surface water. And again, that's 1,500 of the most recent installations across the country. These are our product families. So we have four distinct product families. Mega Treatment, which is mainly focused on water treatment systems. Biohandling or material handling systems is used, for conveying and moving biosolids at water or wastewater treatment plants. And then Delta Separation, which is more of the headworks area or separation of solids between liquid and solids. And lastly, the EcoAir low-profile cascade aerator. That is a system that is installed at the outfall of a wastewater treatment plant and raises the DO from 0 to 6 milligrams per liter in less than 2 feet of fall. So again, just a real quick overview of all the different products that we have. Again, we've been selling all of these, designing, manufacturing all of them for over 50 years. Today we'll focus on the Mega Treatment family and specifically Mega-SETTLERs, which is our plate settler system. So without further ado, I'll kind of just jump right into this. So maybe 15 minutes or so, it's kind of just general information about our plate settlers. It starts off with some fundamentals. Most all of you guys are probably very well versed on this, but the picture in the bottom here, this little blow up where you can kind of see the circular image, it shows 3 different vector arrows, and really what that's depicting is a particle only needs to travel a short distance till it hits the surface. Once it hits that surface, it's forced to agglomerate together with all the other particles. It gains mass, and it starts settling out of the plate settlers. And that's kind of the fundamental principle of how plate settlers work, and why you can put plate settlers into a basin, get more flow through it, get better effluent quality, but all in a much smaller footprint. This next slide just talks about some very early design principles. In 1904, Hazen proposed sedimentation as a function of basin surface area and independent of detention time. In 2009, just skipping forward quite a bit, over a century, JMS received a patent on their top flow control device. And that's an incremental improvement to the technology for a lot of different reasons. It produces a small head loss, which provides even flow distribution across all of the plates. It allows you to walk on top of the plate settlers. And from an economic standpoint, it's a structural component that hangs the actual plate into the frame cartridge. So just, again, some early principles about plate settlers. Application rates and efficiencies. This chart just kind of shows you some different ranges that we see in application rates and efficiencies. We've done jobs at 0.2 application rate up to 0.6, but if I look at probably 500 of the most recent jobs we've done over the last several years, or worked on at least, it looks like the industry average is starting to kind of come to fruition to be about 0.3 at 80% efficiency. That typically produces less than 1 NTU in the effluent, and it gives the operators some safety factor as far as how fast they're operating the system. Now that's kind of industry standard. It's more the average, but again, we've done all different rates, and we can certainly help with determining what is the right rate for your application. On some large projects, we'll send out our pilot unit at size for 110 gallons per minute, and that will be used to derive and get just a closer idea of what is the actual application rate that we need for the water. If pilots aren't needed, again, we kind of default to 0.3 at 80 or 90% efficiency. This is a design program that we've been writing for the last decade. So really what we've tried to do here is any question that we would receive, or most any question we receive, we'd like to have an answer pretty much instantly with this design program. So it's a visual basic design program. It allows us to very quickly provide application runs for a lot of different scenarios. So just kind of taking you through the chart here. So basically, if you hit the JMS button, that's the run button. But coming down through here where you input your data, so we have number of basins, the basin width, the basin length, side water depth, and the basin flow. Very fundamental information that we need to start the design. From there, we input plate geometries, the length, the width, the spacing, plate angle, loading rate, and efficiency. And all of these, we can change all of these. They're all variables. But really what it's going to do, once you put that in and hit run, it's going to calculate how much projected horizontal surface area do you need to achieve that flow at a given application rate. And that's what you're seeing up here. It calculated the surface area required. Then it's going to derive how many plates do you need to achieve that surface area. And at all times, it's looking at velocities through key areas within the basin. So you have velocities through the plates, the settling time up through the plates. We also put in some things here regarding basin overflow rate, the surface loading rate, which is just of the plate settlers themselves, basin retention time, and a lot of these are just items that we kind of keep an eye on. We have rules of thumb to basically provide the best effluent quality possible. Also in the background, it's looking at 10 state standards as far as other velocities within the basin. It's looking at length to width ratios, items like that. In the center of the program, it's going to basically say, we know how much surface area we need, we know how many plates we need, and it's going to do a little bit of rounding, and it's going to fill the basin with plates. So 4 plate packs across the basin, 2 long. Each one of those frame assemblies is approximately 14.5 feet long, and you'll need a total of 8 frames within that basin. Each one of those frames would have 71 plates for a total of 568 plates. You can see there's some rounding there. So really, we're always providing a little bit more surface area than what was calculated, but we feel it's the best choice because you want to have all of your frames the same exact size with the same number of plates in it. So again, there's just a little bit of rounding there, so you get a little bit of safety factor. Next item here on the plate settler program is the trough results. So basically, we're going to size the troughs for a given flow. One thing we do quite a bit, here you see if you click this mark, you can select a maximum flow. So for instance, on this project, we're clicking that, for whatever reason, sometimes you might need to get 8 MGD through this basin. So we use max flow, and we size to accommodate that maximum flow. So that's the fundamental portions of the design program. There are several other tabs that go a little deeper into different design aspects as far as a full array of velocity profiles across the basin. It gets into designing the weir loading rate, the water level within the V-notch weir. Don't have a whole lot of time to kind of go through all of that, but there is more info on additional tabs, and also this is what we're using to, very soon, this design is going to provide an accurate budget estimate. So basically, at a click of a button, we'll have all of that information ready to go. And the reason for that is, I mean, you guys know better than anybody. I mean, things are moving faster and faster every year, and everything we're doing from the sales and marketing side is to have information ready and available to you guys, because when I get a call from an engineer, it's typically that you guys are working on that portion of the job at that time, and we want to do everything we can to accommodate your timing and get you the information in a timely fashion. These next slides get into some little bit more specifics about the JMS plate settlers. So I mentioned earlier you can walk on top of our plate settlers. We have a patented top flow control angle, and you can see that here in this bottom blow up. So basically this provides a flow control gap. That flow control gap induces a small amount of head loss, and the reason we're doing that is you're adding all of the surface area. Now you want to utilize every square inch of that as efficiently as possible. And really, just in the last decade or so, and I've been in the industry about 20 years, even I'm surprised at how many jobs are actually utilizing plate settlers nowadays. And I think there's several reasons for that. The technology has been advanced by us with the top flow control angle, and another competitor that has a different style of inducing head loss. Both you can kind of walk on top of. So there's been two strong competitors really advancing the technology and also making things more economical. We're competing and we're always getting better at our manufacturing processes, things like that. So I think a lot of that has kind of turned into a tremendous amount of demand for plate settlers, which is certainly a good thing. Most of the time when we're talking to engineers, you guys will look at doing life cycle cost analysis. You'll look at doing budget numbers based on footprints and area of a plant, and all of the life cycle cost analysis that we've been involved in over the last probably 5-10 years looks like plate settlers do very, very well when comparing to other technologies out in the market today. So again, just a little bit of info about the top flow control angle and specifically the JMS plate settlers. The next slide gets a little deeper into CFD, or computational fluid dynamics. So 10 years ago we worked with an independent PhD. We had this idea, the top flow control angle. We had hoped for it, thought that it would really advance the technology. It was an economical solution, all of that. So we went to an outside company, ran several hundred different CFD analysis, and came up with what we found to be the optimum design as far as the flow control gap. And some of the things that went into that were selecting the right amount of head loss, because theoretically you can keep adding additional head loss and get a little bit better effluent or a little bit better laminar flow up through the plates. What we wanted to do is achieve laminar flow up the entire surface area of the plate, but we wanted to do that by inducing the smallest amount of head loss through that flow control gap. And another thing we wanted to do with the flow control gap is we wanted to solve some of the issues that we've seen with competitors. We wanted to do whatever we could to solve any clogging issues that plate settlers have seen in the past. And what we found is that the flow control gap spikes the velocity to a high enough velocity at that point that it actually flushes that gap at all times. So if you go to a basin that's been running for 6 months and had relatively heavy turbidity, in any plate settler system you'll see kind of a light fluffy flock all over the top of the plate settlers. One thing you'll notice with the top flow control angle and our plate settlers is the flow control gap pretty much always stays open to flow, and with that being open to flow and not clogging, you're not imbalancing any of the plates. Like you want the same flow at plate 1 versus plate 200 or 400 or 3000. So that's very, very, very critical, and A lot of work went into that as far as proving that with the CFD, proving it in the field. We actually did a big job in Tacoma where we physically measured flow at a 75 MGD plant at different areas throughout the troughs, throughout the plate packs themselves. So that was kind of an interesting exercise out there. The next items here, and I don't go through these a whole lot, like kind of when I'm out and about presenting, and I'll kind of skip through them pretty quick, but we put some slides in here that kind of show the difference between the JMS design and one of our main competitors' design. And some of the main differences are, I mentioned we have a flow control gap. This particular competitor uses orifice holes, provides a head loss, provides good effluent quality, but what we're seeing and hearing from the market is potential clogging issues with heavy solids, leaves, and algae. And I'll kind of just go through some of these a little quicker. This is a picture of our competitor out in California. You can kind of see they had some issues here with heavy solids. There's some other things going on at this plant that they were inducing a little bit of air. But in general, you can kind of see the issues in this, what we feel is a design flaw. Again, there's a lot of these out there. If they're cleaned, they work well. But we're getting more and more feedback from the market regarding clogging issues with heavy solids and algae. So just kind of showing you a picture of what can happen with the competitor's design. We have a V-notch weir. That V-notch weir is always pulling from the surface of the water, so you're never going to end up having a huge buildup of solids. So this plant's been running 6 months or so, so as the solids build up, it has a tendency to kind of back up and then imbalance the actual flow coming up through the plate cellars. The next one, this is a job down in Oklahoma, and actually the plant has called me, and we're kind of working with them and looking at ways to reduce algae issues, and again, this is a competitor's design. And what we're seeing is the competitor's design has about an inch or two of water above their top tube, and it's kind of becoming like a perfect incubator for algae. So we're doing some water temperature tests. The temperature of the water in that stainless steel area above the tubes and all that is typically a couple degrees warmer than the rest of the basin. And again, the nature of the top tube and the orifice holes have a tendency to keep solids, or in this case, keep algae within that zone above the plates longer. And again, it becomes kind of an incubator. It's a little warmer, and now you're keeping those particles in there longer, and then before you know it, you can have an algae bloom. We haven't seen this level of algae bloom with our plate settlers. Again, it's got the flow control gap, and you are pulling from the surface, so it doesn't give time for the algae to kind of bloom. And typically, we have about 5.5 inches of water above the plates themselves. So just, again, some differences between us and the competition. This just shows you can have some leaf issues or anything on top kind of going towards the orifice hole. Another item, we do a bolt-on V-notch weir. So this is an image of our competitors. They do a flat weir that's actually slipped into a sheet metal clip. And feedback from the market on this has been pretty extensive, meaning it's an economical way to do it. If everything's working in a perfect world, it's fine. But what we're seeing is when the basins are cleaned with a fire hose and it hits this surface of the competitor's weir, they have a tendency to get out of balance, out of level very, very quickly. Like this example here was a new installation, and this was just from thermal expansion contraction. You can see there's a 1/2 inch difference between these weir heights. And this design is very susceptible to this weir edge. So the flow coming out of these tubes is much higher than the flow coming out of these tubes. So just by this little bit of imbalance here, that entire section of plates is out of balance, and you're going to get a higher velocity up through this portion of the plates. And again, it's a reason why we bolt on our V-notch weirs, really like you would see in any effluent trough around the country. It follows the 10-state standards as far as the bolt spacing and things like that. Just another image of the competitor's sheet metal clip. So you can see it's very economical, but at the the end of the day, for a long-term solution for the plant, the feedback we're getting is that they have to re-level the weirs quite a bit, and it's very difficult for the plant to do that, especially on large plants. So again, the reason we do V-notch weirs at that location that bolt on and are fully secured. The next couple slides here I'll kind of blow through. These are some testimonials of JMS plate settlers. So Bloomington, Indiana, this was a job with Black & Veatch. So about 15 years ago, I worked on this job when I was at Brentwood Industries as the tube settler product manager. And we put in tube settlers in both of these clarification basins. So this zone here are all tube settlers. Each one of these basins is sized for 12 mgd. So fast forward to about 3 years ago, got a call from Black & Veatch, and they were out of capacity at that plant, but they were also out of room. They couldn't fit the additional basins. They couldn't put a third identical basin right next to that. So really quick from the satellite here, you can see this is 12 mgd of plate settlers at this zone here. So you have the flocculators and plate settlers. So even comparing plate settlers to tube settlers, you can see a tremendous difference in the size of the sedimentation basin and the amount of water you can put through that footprint. So we call and talk to the plant operator, pretty frequently. And the feedback that I've got from them is they can wash down the plate settler basin in literally a fraction of the time of the tube settlers. They don't have to worry about breaking any of the PVC tubes and things like that. And in general, it is producing a higher quality effluent, regardless of incoming turbidity. So just I think a good testimony. And all of these are available in our references, and you guys can call any of them. I'm just going to go through a couple more to kind of give you a little bit of feedback. Danville, Kentucky. This is a this is a plant expansion. They added 4 basins, each one designed at 4 mgd. I was just out there about 2 months ago. Took a picture of the SCADA screen to kind of see what kind of effluent quality they were getting out of the plate settlers. On this particular day, they were getting 0.33 NTUs off of these plate settlers. It's a very, very good number. They weren't at full capacity. But again, kind of just showing what plate settlers can do for you, and really what it did for that plant was they had full filter runs, and just from a maintenance standpoint and the filter runtime and the media loss, with having that full runtime, they were ecstatic that they were getting that kind of quality water to their filters. Let's kind of bounce through a couple of these. This is an interesting one here. Oak Creek, Wisconsin. We have plate settlers in a new part of this plant, a brand new basin. It's right next to an older basin that had the older style plate settlers from, I believe it was Siemens Zimpro, before they had head loss devices and things like that. And then also they have a basin that is just effluent troughs. So kind of a really neat opportunity here. So it's the same influent water, same raw water, same chemical addition, same flocculation, but they had 3 different style set basins. So it's really like a full-scale pilot unit. And the basins that had no tube settlers were achieving about 1 or 2 NTU, depending on the influent and all of that. Basins with the older style plate settlers with no head loss control, they were achieving 1.5-ish NTU, maybe 1 to 1.5. The basin with our plate settlers in the top flow triangle were achieving 0.2 NTU. Now, again, that's a really, really good number. This plant is certainly fine-tuned. It's a really high-quality plant. They've won a ton of awards. They actually sell their water as bottled water. That literally says Oak Creek Water Treatment Plant. And you can buy it at local mini-marts and all that around the area. So it's certainly an impressive plant, but they are achieving high-quality effluent out of Lake Michigan. A project out in Tacoma, Washington. This is a 150 mgd plant. This was a greenfield, brand new site taking water from the Green River, and this is an MWH project. Right here, each one of these basins is 75 mgd, so you have vertical flocculators into a plate settler zone. And one thing they also did is they have plate settlers in their backwash basins because they wanted to clean up and recycle as much water as they could and kind of thicken the solids. So just an interesting job. It's been out there operating very well for the past 5 years or so. Quick recap, and again, I kind of went through it quick, but we're kind of running up on our time schedule here, and I want to be sensitive to everyone's time. But quick recap here. So it reduces the footprint by 50 to 90%. So a lot less land, smaller buildings, less maintenance, just overall less cost. And again, I think a lot of those reasons is why we're seeing plate settlers being so popular nowadays. I mean, we're certainly not getting any more land. If these are in a cold weather climate, you can get the basins to a size that you can actually afford to put a building over top of them. Less maintenance, so really the only maintenance you have is you wash these down periodically. And typically that could be 2 to 4 times a year, depending on the influent quality and your chemical feed program. But as far as the plate settlers themselves, they're going to, what is the life of the plate settlers? We projected at 30 plus years easily, but really if you add plate settlers to that plant, really they're going to be there as long as that plant's operating. Certain things depend there. Maybe if you switch from alum to ferric, but you didn't provide all 316 stainless steel, you have to look at things like that. But typically what we do is we provide anything at or within 4 inches of the air-water interface to be 316 stainless steel. And that's just because that's the most susceptible zone for any level of corrosion. So who knows, in 20 years we might have a new style ferric that it's an awesome coagulant, it's cheap, but maybe it's highly corrosive. So just keep in mind when you're dealing with that, to add 316 stainless steel at just the air-water interface is a pretty economical option that you have just to accommodate any future issues. Just the installation list, but I think that pretty much covers what I wanted to kind of go through. I appreciate everyone spending the time. So I went over a bit, but I see that we pretty much have everyone on the line yet. So I think at this time we should probably open it up to some questions. We can save to a Revit model, and we get more requests for that because I guess a lot of plants are going to the BIM model and all that. So I believe we have access to save to a file that Revit could open and use very easily, and we've done that in the past.
Okay, thanks.
Yep. So it depends on how cold of the climate. I mean, if we get to a project in Maine or a project in Alaska, stuff like that, most all of those jobs are inside a building. So that's one way you can accommodate. Now, if you're more on the edge as far as maybe southern Pennsylvania or something like that, we actually just bid a job in Harrisburg, Pennsylvania, and there were some questions on that job about ice formation. Typically, within a climate that is not, an extremely cold climate, there's going to be enough movement and enough entropy that you're not going to have major ice problems at the V-notch weirs. Now, if you were still concerned about that and it's upstate New York and it's really going to get cold, we do have a design that is a submerged design. So basically, you don't have V-notch weirs pulling from the surface. You have literally a foot or two of water over top of the entire plate settler system, and then basically you're pulling the effluent out of orifice holes on top of the troughs. So that is an option. We don't use it a whole lot. It's a little bit more expensive, and it's not needed as much. That same design can be used in plants that have membranes or filters that are hydraulically tied to a set basin. And we see that a little bit, that every now and then if they're backwashing a filter or a membrane, they say, hey, when we do that, it's going to raise the water in the set basin by a foot. In that case, we can also do a submerged design for the plate settlers. So hopefully that answers your questions on the ice formation and all of that. worked on several desal plants. We have not provided plate settlers on a desal plant yet. As they become more popular, I'm sure we will. But we've done several designs at desal plants all across all across the globe. I mean, some in the States, a lot overseas. Actually, I think we did a couple in Israel, but they haven't come to bid yet, haven't come to fruition. But that is an application that we can certainly provide plate settlers in. As far as the material in seawater, we would be using a duplex stainless steel that's really designed and can hold up to seawater very, very well. And the interesting thing about that is, 5-10 years ago, the duplex stainless steel that we would use for a desal application literally costs like 10 times the amount of 316 stainless steel. And over the years, and actually recently, that delta is really, really closing. So it's starting to make plate settlers, even in duplex, look more inviting and more economical. So that's something we keep an eye on all the time, is just raw materials that are available, what are their costs, because it's one thing that, hey, you can get the material, it will work great, but if it costs too much and it's not within budget, it doesn't really matter. So again, we can do them. We haven't provided any yet, but that's because a lot of those jobs we worked on just haven't moved forward. So I would see in the future that's going to be a pretty big market for us. It's for our internal use. We are contemplating doing a more simplified version that would almost be an app that we could distribute. But right now, that program, it's tied to high-level costing and bill of materials. So if we do give it out, it's going to be a more simplified version that's just regarding the design aspects that you guys would need. So that's in the works. But as of right now, that's an internal program available to us. But one thing nice about it is if you guys need us to run really as many designs as you need, we can do it so quickly, so it's really not a problem for us to do that. I didn't cover it in my presentation, but we're seeing plate settlers in wastewater treatment are becoming much more common. So in Europe, there are tons of plate settlers in primary and secondary wastewater treatment plants. They're making their way over to the States, and what we're seeing is the use on several jobs up in Canada. And actually, we have, I think we have AECOM on the line who's doing some work out in Victoria, British Columbia, and they're utilizing plate settlers in a primary wastewater plant. The reason they're doing that is the footprint and the available space that they have is very, very limited. The land is extremely expensive out there. I think the entire system is going to be in a building for odor control. The building kind of looks like a museum, like it's actually a pretty awesome building. But keep in mind, plate settlers are certainly being used in wastewater plants. This is a picture of our installation in Woonsocket, Rhode Island, and there's 3 basins like this. The plant, it's a 60 MGD wastewater treatment plant, and these are in the secondary clarification, so it's actually treating the water and the mixed liquor right after their aeration basins. Typically, the mixed liquor is about 1,500 milligrams per liter coming into the plate settlers. And this kind of just shows you, before they have their weir set properly in the front of the quiescent zone here, gives you a clue of how many solids were actually coming into these plate settlers. And they handled it very well. These plate settlers had a 4-inch plate spacing, so that's typically what you do when you have, a heavy solids loading. Just kind of go through a couple more images for you so you can kind of see the installation. They had chain and flight sludge removal underneath. Effluent collection troughs, you can see there. Here you can kind of get a sense for the V-notch weirs and the 4-inch plate spacing. So typically in a drinking water plant, the spacing is about 2 inches. So just want to at least take a few minutes and kind of expose you guys to plate settlers in wastewater applications, because again, we're seeing more and more of those. There are two major jobs right now, actually both in British Columbia, that are going to be bidding in the next few weeks to few months that are going to be utilizing plate settlers in a wastewater application. And let's see, I think I had a couple other items maybe that I wanted to show. Well, thank you for your time. Again, we had a really good group on here. Just kind of looking down through the list of names. I mean, some big hitters in the water treatment side of the business. So again, appreciate all of you guys' time. We'll follow up with an email and get you more information.